I just want to briefly talk about the magnetic field around a current carrying wire, assuming it's fairly long, and what happens if you've got two parallel wires a certain distance apart carrying current. So first thing you got to remember is if you have a current carrying wire, there's a magnetic field around it. And you can figure that out given the first right-hand rule I taught you. You take your hand, put your thumb in the direction of conventional current, and your fingers curl in the direction of the magnetic field, and it forms a little circle around it. That gets weaker as it gets further away. So if we do it for this guy, current coming out of the screen, do our hand like that, notice it's going counterclockwise around it. So right where this wire is, the magnetic field is up. The strength of the magnetic field is given by this formula, which I haven't given you before. You might want to write it down. It doesn't come up very often, but good to know. The magnetic field a certain distance away from a current carrying wire is equal to the permeability of free space, that 4 pi times 10 to the minus 7, the cool named one, times your current in the wire, divided by 2 pi times the distance away from the wire. So if we want to find the magnetic field right here, because of this guy, we'd do this. Mu naught times whatever current's in here, divided by 2 pi times the distance between them. And then once we have a magnetic field here, we could figure out what effect it's going to have on this guy by using our third right-hand rule for the, for the current carrying wire in a magnetic field. So fingers point in the direction of the magnetic field, thumb points in the direction of conventional current, force comes out the palm. So straight out to the right in this case. So this guy is going to get pushed away from this guy. And we could do exactly the same thing. I'll leave that as a bit of an exercise for you, but just quickly hand waving it. If we figure out the magnetic field due to this guy, we'd find out it would be clockwise around it. Clockwise around it would be moving up at this point. And so if we have an upward magnetic field there, we could do a right-hand rule again. Fingers pointing up, thumb in the direction of the magnetic field, and this guy would be pushed to the left. So notice if we have opposite currents, those two wires will repel. And we can figure out how strongly they repel. We can figure out the magnetic field of one at one wire due to the other wire with this formula. And then we could sub it in our force formula. So our force is equal to B, which is mu naught times the current in the, let's say the first thing, divided by 2 pi times the distance between them, and then times the current in the second thing, to correspond with this I, times the length of whichever wire is smaller. Because you're only going to have a magnetic field or a wire to push on a distance of the smaller wire length away. Like if one's way longer, that doesn't matter so much because there's only the section where they overlap where we have a magnetic field and wire to push on. So kind of the overlap section. Yeah, and notice magnetic field goes down with R, a distance away from a long wire. And that was related to why the magnetic field was identical everywhere inside a solenoid. All right, so we've discussed why opposite currents repel. We can do exactly the same logic for why identical currents attract. Let's say we've got, I'll just do the case where we got 2 wires going in. You can try it with 2 wires going out. You end up with exactly the same results. So starting with that guy, we figure out what direction the magnetic field is using our first right-hand rule. We find out it will be going clockwise around it and therefore moving down right at this wire. And then we can go into our second right-hand rule, thumb pointing direction of conventional current, fingers pointing direction of magnetic field, and palm in the direction of the force. So this guy will experience a force towards the other guy. And if you do it for the other guy, you'll get exactly the same result. This guy will be pulled to the right, and they'll attract. And this doesn't come up a ton, but it does sometimes, so keep it together, and it yeah, hopefully this helps. Keep well. Talk to you next time.